In today's lecture we've been considering some of the basic ideas behind radioactivity. We started off by considering the early work that was done by Becquerel and Marie Pierre Curie before moving on and looking at Rutherford's observation that the radioactivity of his sources decreased over time. In fact, we could show there was an exponential decrease in radioactivity, and you can see that if we have at time t equals 0, if we have n0 radioactive atoms, after a given time, t, the number of radioactive atoms we have left, n, equals n0 e to the minus lambda t, where lambda is the decay constant, which is particular for particular isotopes and particular elements themselves. So we can see that this radioactive decay leads to the concept of the half-life. And the half-life is the time taken for the radioactivity to decrease by half. And that we can write t a half equals log 2 divided by lambda, where again lambda was the decay constant. So if we know the half-life, we can work out the decay constant. If we know the decay constant, we can work out the half-life. We went on and saw there were three main types of radioactive rays: alpha radiation, which was charged helium nucleuses, positively charged; beta radiation, which was negatively charged electrons; and gamma radiation, which is high frequency electromagnetic rays, or high frequency and high energy. So how do we detect them? Well, alpha and beta are charged, so we can use magnetic approaches. Okay, gamma, we use some more sophisticated approaches to do that. We've seen that alpha is not very penetrating, beta is more penetrating. Okay, beta tends to be stopped by a fairly thick bit of aluminium, whereas gamma, we need quite a substantial chunk of lead to stop. So there's a good way of differentiating between them there. We also saw that we can establish some ideas about where unstable atoms come from by thinking about the forces within the nucleus, so the strong binding force holding the nucleus together, and the electrostatic repulsion. We looked at what happens when radioactive elements decay, and we looked at the decay series. And so, for example, with uranium, we find it decays through a whole variety of different elements before it reaches stability. And finally, we went on and looked at some useful isotopes and had a look at their half-life. So particularly we looked, if you remember, at strontium-90, uranium-235, iodine-131 and carbon-14, which of course is famous for radiocarbon dating, where we can use this regular decay that arises from radioactive decay as a clock, which allows us to date archaeological materials where the amount of carbon-14 is decreasing over time due to radioactive decay. Next time we're going to go on and look at what radioactivity does in the body and some of the damage that can be caused. I also gave out a new problem sheet, and furthermore I gave out your assessed exam question today, or your assessed exam type question. You need to complete this, hand this back into your tutors where it will be marked. Again, it does form part of the continuous assessment, so you must ensure that you do this.